Today we've got an incredible story of innovation for you. But it doesn't come from some fancy high-tech lab or a Silicon Valley startup. Nope. It comes from a primary school classroom, which is just a great reminder of where real change often begins. Let's get into it.
So here's the central question, right? I mean, think about it. We're so used to having all the information in the world right at our fingertips. But what happens when you take that away? When you don't have the most basic tool for modern learning, the internet? How do you keep education not just going, but actually engaging and effective?
Okay, so picture this. We're in a rural primary school in Gujarat, India. The students are in grades 6 through 8. That age where curiosity is just off the charts. The subject is science, which is full of these big, complex, sometimes abstract ideas. And the biggest hurdle? The internet is unreliable, or a lot of the time it's just not there at all.
And look, this isn't just about a bad Wi-Fi signal. It's a huge teaching problem. How on earth do you explain the parts of a flower or a chemical reaction when you can't just, pull up a quick video? How do you make learning an active thing instead of just having kids read passively from a textbook?
Okay, so this is where our hero comes into the story. Meet Sandeep Kumar Prajapati. He's a teacher who saw this challenge not as a dead end, but as a mission. And instead of just waiting around for someone else to come up with a solution, he decided, you know what, I'm going to build one myself.
It all comes down to this simple phrase in Gujarati, which is his guiding philosophy. Read, think, and try. It's not just a slogan, it's a call to action. It's about active engagement, questioning things, experimenting, and truly understanding, not just memorizing. And this one idea, it became the foundation for everything he did next.
All right, so how did he do it? Let's dive into his first and maybe his most revolutionary solution, how he tackled that internet problem head-on.
His approach was absolutely ingenious. He didn't go asking for a bunch of expensive new computers or tablets. Nope, he used his own skills in HTML coding, like the basic language of the web, to build these simple, lightweight quizzes. And because they're just super basic files, they can run on pretty much anything, a smartphone, an old computer, with absolutely zero internet need. And wow, this comparison really says it all, doesn't it? On one side, you've got your standard e-learning, which is basically chained to data plans and a stable connection. But on the other side, total freedom. He completely severed the link between digital learning and being online. He made it accessible to every single one of his students, no matter what.
And we're not talking about some boring, simple tests here. Oh no. He built in all this variety to keep his students hooked. They could drag and drop answers, fill in the blanks, and here's the key part. They got instant feedback. They knew right away if they were on the right track, which is huge for building confidence and letting them learn at their own speed.
Okay, so he cracked the access problem. Check. But what about that engagement problem? How do you make abstract science visible and, exciting?
Get this, he personally created over 75 educational GIFs. 75! And these weren't just for fun. They were super carefully designed visual aids, and each one was built to break down a really complex scientific process, one concept at a time.
Right. Think about how you'd normally learn this. In a textbook, it's just a dry definition, maybe a boring static diagram. It's really hard to picture what's actually happening. But what if you could see it?
But with his GIF, the students actually see the whole experiment happen right in front of their eyes. They see the vapors rise, they see them re-solidify. Something that's literally invisible in real life suddenly becomes crystal clear in just a few seconds. A textbook illustration could never, ever do that.
All right, so now the learning is accessible, it's visual, but Sandeep Kumar didn't stop there. He took it one giant step further. He decided to make it fun. He turned learning into a game.
He tapped into something we all know works: gamification. He took the regular curriculum, all the facts, the vocabulary, the concepts, and basically hid it inside games that kids would actually want to play.
And the games he built are just so creative. They don't feel like a test, they feel like a real challenge. I mean, in Balloon Pop, you're not just clicking an answer, you're aiming at a moving target with the correct term. It totally transforms studying from a chore into something genuinely rewarding.
And listen, there's some serious educational science behind all this fun. The instant scores, that builds confidence. The leaderboard, that sparks a little friendly competition. The ticking clock, that helps you focus. It all works together to make students more motivated, and, this is crucial, it helps them remember what they've learned, because the experience itself was memorable.
Okay, so let's take a step back and look at the big picture here, because the offline quizzes, the GIFs, the games, these are more than just clever tricks.
They're all part of a much deeper philosophy about what education really should be.
This right here is the core idea. It's called inquiry-based learning. It's all about turning students from passive listeners into active investigators. The goal isn't just for them to spit back facts for an exam, but to understand concepts so deeply that they start asking their own questions and hunting for their own answers.
And this quote, this might be the most powerful part of his whole philosophy. In his classroom, a wrong answer isn't some big red X of failure. No way. It's a prompt. It's like a little flag that pops up and says, hey, hold on, let's think about that. Why didn't that work? It completely reframes mistakes as a vital part of learning. So when you put it all together, the real goal isn't just to get kids to pass tests. It's about building skills that they'll carry with them for the rest of their lives. The ability to observe carefully, to think logically, and to solve problems on their own. That's the real lesson here.
And that really leaves us with this one big question to chew on. We're always looking to these big tech companies or government policies for the next big thing in education. But what if the most powerful, most relevant innovations aren't coming from a boardroom? What if they're being built right now in a classroom by a teacher who just gets it?